Welcome to the University of Pittsburgh Health and Explainable AI podcast, a collaborative initiative between the Health and Explainable AI HexAI Research Laboratory and the Department of Health Information Management at the School of Health and Rehabilitation Sciences, and the Computational Pathology and AI Center of Excellence, CPACE, at the University of Pittsburgh School of Medicine. I'm your host, Jordan Goss-Poire, a health and science reporter. In this podcast series, we explore the transformative integration of responsible and explainable artificial intelligence into health informatics, clinical decision-making, and computational medicine. From reshaping diagnostic accuracy to enhancing patient care pathways, we'll highlight how AI is creating new bridges between researchers, clinicians, and healthcare innovators. Led by Ahmad P. Tafti, Houman Rashidi, and Liron Pantanowitz, the HexAI podcast is committed to democratizing knowledge around ethical, explainable, and clinically relevant AI. Through insightful conversations with domain experts, AI practitioners, and students, we'll spotlight the latest breakthroughs, discuss real-world applications, and unpack the challenges and opportunities that lie ahead in responsible AI in healthcare. So, whether you're a student, practitioner, researcher, or policymaker, this is your gateway to the future of AI-powered healthcare. Today, on this podcast episode, we're going to speak with Dennis Wei, Senior Research Scientist at IBM. He specializes in human-centered, trustworthy AI. For the benefit of students, researchers, and healthcare practitioners, we're going to discuss explainable AI in detail, and we're going to discuss Dennis's work around in-context explainability. Welcome, Dennis. Thank you so much for joining us. Would you like to introduce yourself and tell us a little about how you first became interested in artificial intelligence and machine learning, and what's driving your interest today?
Sure. So, as I think you've already mentioned, right, I'm a research scientist with IBM Research. Specifically, I live in the San Francisco Bay Area, and I'm based at IBM's Almaden Research Center in San Jose. And in terms of how I became interested in machine learning and AI, it was a gradual process. So, my PhD was actually not in computer science. It was in electrical engineering, specifically in this area called signal processing. The thing that I will say about it is that it required similar mathematical background as what I now use for machine learning and AI. And so it was not an unnatural progression. And over the years that I've been with IBM Research, I've basically drifted more and more into machine learning, until there was a point where I became wholly a machine learning / AI researcher. So that's a little bit about my journey.
What are you excited about today, and how is this driving your current work?
Yeah, so over the last couple of years, 2 or 3 years, I have mostly been focusing on explainability, right? And in particular, explainability for LLMs, large language models. Just basically trying to understand them better from various perspectives. So that's what's been occupying me lately.
So normally, we incorporate a couple of questions about explainability into all of our interviews. But today, we're going to focus entirely on explainability, which is something that you're interested in, and it's great that you've mentioned this subject already. So diving into explainability, as a researcher, when you sit down to study explainability, what's foremost on your mind?
Let me start answering this by saying that there are, of course, different kinds of explainability or explanations. And with respect to LLMs especially, since they can generate text extremely well, right? One might ask, why can't we just ask them? Why can't we just prompt them for explanations? The issue that I and others see there is that, the explanations that we get from just prompting them, they could be just something that the LLM is, quote, saying or generating, right? But it may not reflect their actual behavior or the actual underlying mechanisms, right? What they are actually doing, so to speak. So my interest, and again, let me be clear, right? It's not just me, it's of other so-called explainability researchers. We are interested in what I would call deeper kinds of explanations, right? Ones that are really grounded in what is actually going on. What is the LLM actually doing or, quote, thinking when it's provides a certain response or behaves in a certain way.
Many researchers loosely refer to large language models as black boxes that are challenging to truly understand. From an explainability vantage point, how closely today can we understand and explain how large language models generate question outputs?
To some extent, I would actually say the problem has gotten better in that, before LLMs, we also had complex AI models, but they weren't able to speak, right? They weren't able to generate text and tell us at least something about what they might be thinking, right? So, to pick up on my previous response, the issue is not so much that they cannot explain themselves, it's whether we actually trust that the explanations that they're giving actually reflect their behavior, their mechanisms, right? We want explanations that we can actually trust. That's the issue.
For regular users of AI search engines and new AI-powered browsers like Perplexity's Comet browser, we've become familiar with explainability through source attribution, where a tool will list a website or websites that it pulled information from to generate an answer to question prompts. If source attribution is the explainability for beginners, what does intermediate and advanced explainability look like? Thinking about how LLMs work and how we interact with them.
Yeah, I'm not sure I have 3 levels, but let me answer this by describing the difference between like the source attribution that you're referring to and the somewhat deeper kind of explainability that I am after. Right. So to me, source attribution means it can be a post hoc thing in that the LLM generates some response. And then it looks for sources that justify that statement or support that statement. So this is support in a general sense, in that the response has already been, written down on paper, so to speak. And in fact, the response doesn't have to have come from the LLM. It could have been generated by, it could have been produced by a human. Source attribution still works the same way. Given this response, we're looking for sources that support it in this general sense. The kind of explainability that I am after, that I'm interested in, is what actually caused an agent, in this case the LLM, to produce this response, right? So it's not so much a post hoc thing anymore, right? It's inquiring into the behavior of the LLM. Which sources did it actually use to produce this response or this answer?
Okay, before we dig deeper into explainability and LLMs, maybe now would be a good time to talk about IBM's AI Explainability 360 Toolkit and your in-context explainability toolkit.
Yeah, so just to clarify first, yes, the toolkit is in-context explainability 360, the new toolkit, I should say, and we use the acronym ICX 360 for it. The AI explainability toolkit that you mentioned also, that is actually an earlier toolkit that we at IBM Research put out, it's 6 years ago now. So AI explainability was, of course, at the time it was for more traditional machine learning models. The new one now, the ICX 360, this one is focused on LLMs. And in particular, it aims to explain the output of an LLM, so text output, in terms of the input context that's provided to the LLM. So I want to clarify that too. So by input, I mean, it could refer to anything in the, anything that we put into the LLM, in the so-called prompt. So this prompt often contains context. And by context, I mean things like documents, background information. Sometimes people provide so-called in-context examples, demonstrating to the LLM what it should be doing. So all of these are considered as context. And we want to explain in terms of these context elements. But I wanted to say that this notion of input is broader than context too. So the prompt could also contain like an instruction to the LLM. saying what it should be doing for this task. So we can also explain in terms of elements in that instruction. In other words, is the LLM really paying attention to, say, the keywords in the instruction? So we can interrogate that too. But overall, we're looking to explain in terms of what parts of this input or context were more important for the LLM to produce its output, to produce its response.
For students and researchers who'd like to try out your new in-context explainability toolkit, what basic getting started advice would you offer to help them set up their workspace, plan their research, and get started?
Yeah, first of all, we've made it openly available, open source. So the first thing to do is to go to our GitHub repository. We have instructions on how to install it, in your computing environment. And we have materials there, to get it installed, to get started. So we have some example Jupyter notebooks showing how to get started with each of the methods that are in the toolkit. For people in the kind of healthcare space, what I would say is that you can try it out on ways that you currently use LLMs. So, I'm not a healthcare person by any stretch, but one thing I imagine might be of interest is taking as context. So, recall I was talking about this concept of context, the context that we're providing to the LLMs to answer queries. You could provide as context, say, a patient's medical notes, right? Or maybe even their whole electronic health record. But let me start with the medical note, because those are usually in text format, right? And so that could be your context. And then the task might be to, say, summarize notes from, over a certain time period, let's say, or answer a specific question that either a doctor or a patient might have about this patient's medical history, right? So that's an example of how, I imagine that a healthcare practitioner might be using an LLM based on context. And then what our toolkit could provide is, so let me go with the summarization example, right? So say the LLM has produced a summary of the patient's medical notes. We can then see, for each, let's say, sentence in that summary, we can see which parts of the patient's medical notes were actually important in generating that sentence in the summary. So that's the kind of insight that our toolkit can bring.
In the future, can you envision your toolkit or other explainable resources tuning themselves for different users and use cases? For example, it might explain the workings of an LLM differently for a doctor than it would for a patient.
Yeah, this question of personalization is interesting. It's not one that I've thought of yet with respect to this toolkit. So the explanations that we're providing they are specific to an LLM, right? So they're getting at this LLM's behavior. Now, how to make that personal to the user?
Before you answer, we like to close our interview by asking guests to offer students a research project idea. But maybe students might like to look into personalizing explainability toolkit outputs.
Yes, exactly. Yeah. What I was starting to say is one way I could see this happening is that, yes, the toolkit is explaining, say, this LLM, granted to be concrete, let's say, but maybe, there is some tailoring of that explanation or some emphasis or de-emphasis that we could put on it that would make it more suitable for a given user. So that's one idea that comes into my mind.
In the way of collaboration, how can you envision Pitt's Health and Explainable AI Research Lab and Pitt's Computational Pathology and AI Center of Excellence collaborating with IBM on explainability research and being of use to your team? So, maybe in general terms, how can you envision collaborative relationships working with university labs and centers of excellence based on directions that you would like to take with your research and your toolkit?
So I gave one example of how I imagine a healthcare practitioner might both use an LLM as well as use our toolkit to explain that LLM's response to a query. That's just, my thinking or, my imagining of what it might look like. So one thing that I would be interested in is actual real examples from, actual healthcare practitioners. Examples of such use cases, or maybe even better, like whole data sets of such examples, right? So that we can better specialize to, your application rather than just me, going off and pontificating about it, right? So yeah, the first thing is to make our examples, our use cases more real, more grounded to your experience. Another thing that I can say is that we would be interested in knowing, like I mentioned, there are different kinds of explainability, earlier in this interview. So we would be interested in knowing, like, what kinds of explainability are you looking for, right, as healthcare practitioners? Is it the kind that we are providing, or are you looking for something else, right? That's another way that I think would provide, future research directions to us as AI researchers to be more useful, right?
Since we've already talked about research project ideas for students, what are you excited about at the cutting edge of explainability, and what would you love to work on?
I'll mention a couple of things, if I may. So, a few things actually. So, first, closer to the this ICX 360 toolkit that we've been talking about, one thing that I'm excited about is expanding its scope, right? So, as I've described, the current toolkit is focused on the so-called input to the LLM, right? The text that we are putting into it and explaining in terms of that. I'm interested in expanding the scope to also include text that the LLM is itself generating, and in particular, so-called reasoning text, right? So you may have heard that the later generations of LLMs are capable of reasoning, reasoning in, I guess, quotation marks, right? Where they generate a lot more text, supposedly detailing the steps in their thinking process, right, before they arrive at some final answer. So I am personally interested in extending this kind of explanation to also explain in terms of these reasoning steps. So which of these reasoning steps were actually influential to the LLM in arriving at a final answer? Because I think the suspicion, or the realization among the AI community is that, while this kind of reasoning helps, it also seems quite inefficient. Like, if you look at the reasoning steps, the so-called reasoning traces that these models produced, they're very wordy, and they kind of meander. They're steps that don't seem necessary. So, being able to really quantify that is something that I'm interested in. So that's one thing. And then another thing, if I may, so this is actually farther afield from ICX 360, right? So as I mentioned again, ICX 360 is focused on explaining in terms of the input. In terms of the cutting edge, though, in the last few years, there has grown this other area that goes under the name of mechanistic explainability or mechanistic interpretability. And that is really aiming at explaining not just in terms of inputs or kind of surface things that we can already see, but rather in terms of the model internals, like, internal components of the model, or, explaining in terms of, which internal components are more important for a given behavior, or even trying to, like, reverse engineer the algorithm or the mechanism that the LLM is using for a given task. Yeah, so this area has really exploded in the last couple of years. It's exploded so much that I even struggle to, like, describe it succinctly, but it's something worth looking at, definitely. And I would liken it to, like, it's almost like, scientific study of LLMs, taking LLMs as not a biological organism, but, some kind of being that deserves study in its own right, right? So it's kind of trying to look into these things that we've created and understand them from like a scientific point of view. So that's the other thing I would mention.
You mentioned letting large language models study patients' whole electronic health records and seeing how LLMs might interpret a patient's health and medical conditions. As a research project idea, and maybe even something that university research labs could collaborate with IBM on, how could you envision insight on how LLMs reason over research problems, generated through explainability studies, could be leveraged to help teach LLMs how to approach specific research tasks in a more streamlined and efficient manner? Can you rephrase this idea and what we're talking about here and offer your thoughts on doing something like this?
Yeah, so I will pick a use case closer to what I am familiar with. How should I put this? Like we're not reading medical images here, right? For instance, that's something quite totally different. So maybe coming back to the example that I gave of feeding an LLM a patient's medical notes or their whole electronic health record, maybe there is an opportunity to teach them how to be more efficient in that, right? So their strength is that they can ingest a whole lot of data, right? That it would maybe simply be impossible for a human doctor to read and absorb and recall everything from. So that's maybe the strength of LLMs, that they can ingest all this information and not suffer from human biases of related to limited memory and so forth. But at the same time, if say we're asking them to perform some say medical reasoning, right, like help a doctor make a diagnosis on a patient, for instance, maybe there is something that explainability tools can reveal about how that reasoning process could be more efficient, could be guided in a better direction. That's my speculation on this topic.
Dennis, this has been such an interesting conversation. To close our interview, would you like to share any final news or give a shout out to your team?
Yeah, so I'll definitely give a shout out to my fellow developers of ICX 360 and in particular my co-lead, Ronnie Luss. I think the two of us have, really put in the most into the toolkit. In terms of future events, we will be presenting something on it at the AAAI conference, definitely. So AAAI is probably the biggest conference in AI in terms of just attendance and breadth of topics. So that'll be happening in January and in Singapore this year, or next year, I should say. And we'll be presenting something both on ICX 360 as well as, our group has put out I hesitate to call it a sister toolkit, but it's also a toolkit that our research group has put out on steerability, or steering LLMs to behave in certain ways or modify their behavior. Yeah, so we'll be showing something on how you can combine both steering or explaining steering and then inspecting again to see whether the steering that you have put in place has actually had the intended effect. So that's something to look forward to.
IBM's explainability work looking at steerability is really interesting. Thanks for sharing news about this new toolkit too.
Yes, thanks so much for having me and for thinking of me again.
Thank you so much, Dennis. It's been a pleasure speaking with you. Thanks for taking the time to join us on Pitt's Health and Explainable AI podcast.
From the University of Pittsburgh, thanks everyone for tuning in and for following the series. Join us again on HexAI, where we explore the transformative integration of responsible and explainable artificial intelligence into health informatics, clinical decision-making, and computational medicine.